Hello, everyone. Thank you for joining. We're going to give everyone just a moment to join. So thank you for your patience. Welcome, everyone. We're giving everyone time to join the meeting. We'll get started in just a moment. Hello, everyone, and welcome to today's webinar. I'm Robin Carr, and I'll be your moderator for today's event. Thank you for being here. Before we get started, I have a few housekeeping items to go over. If you lose audio or visuals, simply exit GoToWebinar and come back to reset your connection. The chat feature is available in your upper right-hand corner of the GoToWebinar screen and should be used only for general comments or for requests for technical assistance. You can ask questions using the questions feature, also available in the upper right-hand corner of the GoToWebinar screen as you think of them. The presentation is being recorded and will be available on our Fluke YouTube channel within a few business days. We'll hear from our speakers, and if there's time, then we'll go into a Q&A session and we'll answer as many questions as we can in the time available. Don't worry, post those questions. If we run out of time, we'll send your questions to our speakers for direct answers. Our presenters today are joining us from Optimal, an organization that understands the critical role your assets play in achieving your business goals. We have Dr. Leslie Moyo. He's a director at Optimal and a global asset management expert. Shalom Ndlovu is a principal engineer at Optimal, specializing in maintenance planning and digital reliability tools. And Zulfikar Umar is a predictive maintenance specialist here at Fluke with over 25 years of experience leading connective reliability programs. All right, you're here for Simplify Your Maintenance Strategy, Connected Reliability in Action. Dr. Moyo and team, take it away.
Thank you so much, Robin. Good day, all. My name is Leslie Moyo, and we're here to talk to you about how you can simplify your maintenance through connected reliability. As Robin has already said, I'm one of the directors at Optimal based in Aberdeen, Scotland, and I have over 25 years experience delivering operational asset excellence across various industries. I hold various qualifications, including a doctorate from Strathclyde University. So asset management presents us with opportunities and challenges. In particular, predictive maintenance can enable an up to 20% reduction in OPEX. The challenge we have from asset is that 82% of our failures are random. And as a result of that, unscheduled downtime can cost up to $500,000. And because the failures are random, it's likely that you could see this cost. You're also looking at potentially HSE risk issues as well that need to be addressed. And the opportunity here is that there's potential to leverage condition-based maintenance and predictive analytics. For example, an investment of up to 10,000 can realize up to £500,000 in savings. And how did we get here? We started off with reactive maintenance, where with fixing things on fail over the years, and we moved on to statistical prognostics, which was data driven, and we're looking at what is the health of the asset. We then moved on to diagnosis. We're looking at machine health, looking at scenarios and how future failure could be prevented. And then we're now talking prognostics, and we're looking at what can it do when failure occurs. And that is where the power lies. But to leverage that connected reliability, you need the appropriate platform. And on the one hand, you also need your clear asset strategy, as well as delivery of those asset strategies on the ground. And connecting the two, taking advantage of your OT, operational technology, and IT data is an industrial management platform which can provide you with the background and the support to effectively deliver connected reliability. Connected reliability delivers predictive maintenance, and predictive maintenance varies in terms of complexity and automation. On the low complexity, low automation end of things, we've got condition-based rules, which are simple and just require manual application. On the high automation end, but still on low complexity, we've got guided analytics. And guided analytics offer high automation with simple user guidance. On the high end of complexity and but low end of automation, we've got advanced analytics, which involves complex models with minimal automation. On the high complexity, high automation side, we're looking at automated analytics, and which use complex algorithms and really high automation. So these are some of the approaches that are available, and I'll hand over to my colleague Zof to talk to you a little bit more about some of the specific techniques. Zof.
Hi, thank you to Leslie for that. Could I maybe just ask that you give me back the control for the slide? So my name's Zulfikar Omar. I'm with Fluke Reliability. I'm the sales manager for Africa. I've been in the condition monitoring field for over 25 years, mainly in predictive maintenance and asset efficiency optimization on rotating equipment. My focus has been on the connected technologies, remote diagnostics, and cloud-based solutions. I'm passionate about the products that we have and the software and services that drive the connected reliability journey. I have a BTech in mechanical engineering, and I'm a certified vibration analyst Cat 3 and infrared thermographer. Just give me a sec as we change. Okay, so my place today is to talk about the 5 steps. Oh, sorry, yeah, jumping ahead here. The 5 steps to running an effective condition monitoring program. And today we live in a high-paced, consumer-driven society, which forces businesses to adapt or die, and competition is strong, requiring manufacturing at every level to produce product fast, efficiently, and at high quality. I'm sorry, I'm having some issues here. There we go. This is achievable when manufacturing. I've got a trigger happy key. There we go. This is achievable when manufacturing processes run smoothly and operations are not plagued with unplanned stoppage. However, it puts immense pressure on the maintenance and engineering teams to ensure high availability of equipment and delivering on a reliable, stable manufacturing process. Traditionally, maintenance strategies were developed in the 1900s are still practiced today, but do they really address today's need for speed, efficiency, and cost effectiveness? This is the challenge that we are faced with as engineering teams in all industries. Thanks to the fast-growing growth of technology, condition monitoring programs such as thermal imaging, acoustic emission, vibration, and oil analysis are widely available and affordable. And these programs, when used effectively, can be employed to close the gap and provide meaningful information to drive modern-day maintenance needs. Apologies again. There we go. So presently we're in the, sorry, I've got a problem with my slide deck. There we go. Sorry for that.
Shall I move it for you? Shall I move it for you, Zof? Let me know which slide you want.
I think it's going to work. I think it's going to work better, please. Can we go to the next slide?
Okay.
Thank you. So presently we're in the fourth iteration of the Industrial Revolution, or Industry 4.0. And this succinctly described by the term connected reliability. And this is best explained as a program using the right detection technology to predict early on the progression of component failure in plants through skilled analysis and providing the right message to the maintenance and operations team, enabling optimized asset management. The question on every maintenance manager's mind is not what to do, but how to do it. And for a program to be successful, it needs to be easily implemented, simple to manage, affordable, and effective. And it needs to show tangible results quickly. And this is where I hope that the questions, I can address these questions with the 5 steps. Thank you. So the first one is reviewing your asset plant. I'm sorry, there we go. So we need to determine where you are in your maintenance program right now. Identify the gaps, review the bad actors, and assign criticality to your equipment fleet. Define the goals of the program. Know your plant. What are the types of equipment that you have to maintain? Classify them, whether they're simple equipment at constant speed and load, or complex equipment with multi-shafts, different speeds, variable speed and load conditions. Assign criticality across the equipment fleet. So if this machine stops working tonight, what is the impact on the production process? And how quickly can it be brought back online? And this will give you a good idea of where you need to focus your energies and your resources. And armed with this information, we can move on to the next step, which is to identify the right technology. So what is the best practice for monitoring this equipment? The majority of plant equipment can be monitored using routine vibration data collection. Oil sampling is also very effective where applicable. Some faults, such as leaks, are best identified using acoustic emission. And of course, some electrical faults and mechanical faults can be spotted using thermal imaging. Typically, you'd need to use a mix of these technologies on most plants. And the technology you used should match the criticality of the equipment. An example of this is for monitoring a multi-stage gearbox, one could use oil sampling, vibration analysis, or thermal imaging. And if done routinely, all of these could be effective in identifying a fault within the gearbox. The difference, however, comes with how early the fault is detected by each of these technologies. Early detection means more time to prepare contingency and to ensure that equipment is taken offline, repaired, and replaced with the least amount of downtime. So choosing the right technology with the right frequency of monitoring will deliver the best results. So predictive maintenance programs require regular routine monitoring with historical trending. How did this machine operate 3 months ago versus how it's operating right now? So you have to have an understanding of whether there's an overall measurement increase, or is this measurement that you're now getting up to in industry standards, is the machine safe to operate under the current conditions? And all of these can be answered through a well-run condition monitoring program. So the next step then would be to define the need. Assuming we've done the first 2 steps and we have a complete equipment list, we've ranked the criticality, we've identified the bad actors, and we know where we need to deploy our time and resources. Secondly, we've decided on the best fit technology to monitor the equipment, and we've drawn up a schedule of how often we want this to happen. So 2 questions should come to mind at this point. Does the team have the skill set to use the technology? If the answer is yes to this, then you've got to ask the question, what's the maturity level? And this will determine whether you go forward with an entry-level monitoring program or a more advanced one. If the answer is no, and that you don't have the skill within the team, you've got to decide whether to outsource to a service company or to upskill the team. And if upskilling the team is the next step, then you've got to determine what training is necessary and how long it takes to get the team fully functional with the new program. The second question you'll have to ask is, once the data has been collected, do you have the ability to provide meaningful recommendations to drive corrective actions? And again, the question is, if the answer is yes, then do you have the systems in place to manage the reporting and to integrate into a more concise or your current CMMS or your management system? If you don't have the capabilities or the skill set, then the question goes back to, do you outsource this or do you need to train up your team? These two questions will ultimately determine the type of condition monitoring equipment you acquire. Is it easy to use? What kind of training, product training is required? And in some cases, the equipment is easy to use, but does it reduce, if it's easy to use, and does it reduce the capabilities that it can offer? So usually there's a need to start with an entry-level equipment set for ease, and then to progress to more advanced equipment and skills as the team progresses in themselves. We can go to the next slide. One of the main aspects, or the hardest part of a condition monitoring program, is motivating commercially for the equipment. So once you've decided on what to monitor, how often, and what kind of technology, you now need to look at funding for the purchase of the right type of equipment. And the best way to do this is to run a return on investment calculation. Determine the impact on the business if the plant or the manufacturing process is stopped. Look at the cost of the unplanned stoppage versus the planned maintenance downtime. And quantify how much of inventory is necessary to ensure spare part availability. Highlight the costs of outsourced repair or maintenance. This can be done for the critical assets first, and usually the cost implication is high enough to consider acquiring condition monitoring tools to mitigate this risk. In my experience, though, when embarking on a condition monitoring program, small steps with a long-term goal is the most sustainable way to go. So look at purchasing equipment that meets your basic needs, but has the capability to be upgraded to a more advanced functionality as you progress in this journey. Include upskilling of the team to your plan, and tap into the training budget or look at the human resource retention to ensure that your programs remain as a core function of the team. If we can go to the next slide. Defined the process to run a condition monitoring program. So now you need to implement the routine religiously and act on your findings. You'll not always make the right decisions at first, and some failures will still occur, so keep track of your hit rate. On the occasions when you've missed a failure, learn from it, put in place measures so that it doesn't happen again. Quantify the loss so you can assign an impact to the failure, and improve your processes and continue to identify and close the gaps. Continuous improvement is the name of the game. Where you have won, celebrate your wins. And when you have averted a failure, quantify what that means. How much did you save by not having that equipment go down? In most cases, this is the step most neglected and most detrimental to the continued success of your condition monitoring program. Both the failures and the wins, if documented, can be used to motivate for further funding and enable you to keep abreast with the latest condition monitoring trends and technologies, and ensure your program expands and improves with time. So circling back to the term connected reliability, and in light of the 5 steps presented, you want the ability to listen to what your machine is telling you so that you can react early enough to ensure your plant is running at optimal conditions. Sometimes it's necessary to partner with the right reliability partner to ensure you implement the program effectively and you get the best return on your investment. So at Fluke Reliability, we have the right products, the software and the training, and the services to get you connected to your plant. And thank you for the time, and I'm going to hand over to Shalom to do the next part of the presentation.
Thank you very much, Zuf. All right. Yeah. Thanks again, Doc, and thank you, Zuf, for what you've said already. And talking to connected reliability, I'm going to take everybody through a case study that we've got. This is a company that's here in South Africa, but before I do that, I'll just introduce myself quickly. So I'm Shalom Lobu, and I'm the principal consultant for Optimal. I've been with the company for close to 8 years, and most of that time I've been working within the asset management and reliability engineering space, doing a lot of work within the mining space, within the FMCG space, energy space as well. And yeah, that is growing each and every day. I am sort of loving the space within the asset management, and that has made me to even do my master's, which I'm currently embarking on right now in engineering management, but with a special focus on asset management. So yeah, that's me quite loving the asset management space, as it were. Now, with regards to our case study, we have a company here in South Africa that is currently using one of our solutions, and like my previous presenters have already alluded to, really the biggest issue that we have, and this is world over, is all around, most of the companies being reactive and not being aware of what exactly the problem is with regards to their equipment. Now, this particular client as well had the same problems and issues. They are in the water space, so they provide pumped water to different spaces within the northern part of South Africa. So basically, they are a bulk water supplier, and they treat that water, and after treatment, that water is then pumped to different areas within the province. So that being said, they can't afford to have any downtime of any sort because, as you know, I mean, water is a very, very essential resource in all over the world over. So they can't afford to have any lack of that resource. And that is one of the biggest problems that they had, being reactive, and also the management not getting visibility in terms of how healthy are their assets, and them not being able to even have any way of predicting what's going to come, in future. And when we then came in or came on board with them, our objectives were very simple. Give these guys enough information to be able to make decisions well ahead of time, be able to detect anomalies for them, so that they're using real-time data so that they can also, again, make decisions well ahead. And also to give them a platform that will be easy for them to use. Obviously, from our side with Fluke, we are experts in what they do and what we do, and it's not always the case with clients outside. They need something that's quite simple and they can understand. And based on that, we then decided that we were going to give them our Azima DLI solution, which is a very, very simple and yet powerful tool, where we use wireless sensors, and the wireless sensors collect all the data, and that data then runs through our very powerful AI engine and looks at different failure signatures that the equipment has, and sort of compares those failure signatures to the huge library that we already have, and then sort of give then the clients the different uh, sort of identified faults and also what needs to be done. Now, in terms of the system architecture, as I've already said, quite a simple architecture. We installed sensors there. These are Axo 360 sensors, and these sensors sort of vibration monitoring or vibration sensors as well as temperature sensors. So just one sensor can pick up temperature as well as vibration. So we installed 4 of these sensors, 2 on the motor and 2 on the pump itself. So obviously, on the drive end and the non-drive end of the pump and of the motor, both of them. And then the way that the system currently is set up, these sensors then connect to what we call the gateway. And also all the data from the sensors then is sent onto the gateway, and that gateway then transmits all that information onto the cloud. Again, given the remoteness of this particular client, we are using cellular LTE connectivity. that simply means that we put in a SIM card onto our gateway, and that is how our gateway then connects onto the server. Now, at the back end of all of this is our powerful diagnostic software, which is our Alert 5 diagnostic software, which basically then at the moment looks at all the data that is coming through from the sensors to the gateway and diagnoses that data, as it were, using our over 6,000 diagnostic rules. Now, obviously, these diagnostic rules are things that are the rules that we have developed over time. We, like Zulfa said, we are experts within this particular space. So we already know, and the system already knows, how each particular failure gives, what type of failure pattern does it give. So if you're looking at wearing or your whatever failure that you're looking at, the pattern is already been predefined. And so when all this information comes through to the server, our systems are already looking and comparing. And from there, our client then got a predictive portal, which is the end user side of things, where they get to see exactly what the information or what the problems are that the equipment currently has. In this particular case, with regards to this particular client, we were able to give them a dashboard, which is what you're looking at right now, which is the pump. And this dashboard for the pump basically shows the client the health score of their pump. In this case, it's sitting at 75%, which basically means to them that there are some problems that they need to be mindful of, or need to look at, or maybe they need to solve, as it were. Now, the system from the get-go, once we installed it, it was able to pick up different problems. And in this case, it picked up that there is wear on the bearings for the motor, and that also there is wear on the bearings of the non-driving side of the pump. Now, these faults, as it were, or problems, the system then categorizes them into different severities. So in this case, we have got 2 moderate and 2 slight. So slight obviously means it's at the bottom. It's something that is not as big, but moderate is probably in the middle, and we need to probably look at that. And again, like I said, this particular solution that the client is using is meant to be simple and easy for them. And so one of the things that it comes with is recommended actions. So the system will automatically give recommended actions to them to say, this is what you actually need to do. So based on the signature that is saying, it will then give recommended actions. Sometimes it could be grease your motor, it could be tighten loose footings, as an example. But the system is well trained to identify all different faults and also give recommended action, something that the client can actually then do. So in this case, you can see that it's already given them some recommended actions that they can do. Now, moving on to the next slide here, what I've done here is to put for you the screenshot that shows each different failure that the system has already picked for them. Now, like I said, the system sort of isolates each individual fault and can then track that. So the client is able to see how each fault is trending or changing with time. So in this particular case, you can see that that motor bearing wear is sitting within moderate. And as time is going, it is changing, so it can either get better or get worse. Sometimes you might find that it gets better because the system would have recommended that you go and grease, and after greasing, then the severity sort of goes down. But because it's something that will be there forever, you will find that it will start going up again as time goes on. So you can see in this particular case, our client has got different failures, and some of them are moderate and some of them are slightly lower. But this, at the end of the day, gives them an idea in terms of how fast the failure is progressing. So if your gradient starts to go up, then you already have an idea as to what is happening within your equipment, which then goes back to what Dr. Moyo was talking about, avoiding what we call random failures, as it were, because with this, now you're able to see exactly what the problems are, and you can see how those problems are sort of progressing with time. And our client in this particular case do have condition monitoring teams, and so our system is also able to give them an in-depth spectra data as well for them to go and look at per sensor that has been installed. So in this particular case, you can see here we're looking at the single spectra, and we are able to see the different times. And for the condition monitoring teams, they are able to then use this as well for further diagnostics in understanding what exactly the particular issue is with their motors or their pumps. We have also gone ahead and given them the alert management platform, which comes with the system anyway. And this platform allows them to be able to see all the alerts that the system has created. In this case, there's an alert to inspect the coupling because the system has already picked up a coupling wear fault signature. So it's monitoring that coupling wear fault signature and has asked the client to go and inspect and check if there is actually wear on the coupling, right? So the client is then able to come onto the portal, manage those alerts. So in this particular case, you can see that this particular alert is still open. That means somebody needs to be assigned that particular action. So in this case, someone will be assigned that action, and they will go and then check if there is visible wear or not, and then they will come back and give feedback onto the system in terms of what they found, and that log is stored in here, and this can then be also pushed onto the CMMS that they use should they want that. What I love about this is that the client at this stage can see how old these particular actions have been. So as soon as the system picked up that there is coupling wear, it created an action, and that action has been here for 4 days. And so we can easily see, how long that particular action has been and what the current status of that action is. And the nice thing about this is that even us as Optimal, we've got our own command center where we are constantly monitoring the different alerts for all the clients that are using the system, and we're also able to alert them as well if they don't react accordingly. So based on the SLA that we have, we will then alert them according to that. Now, from there, the next slide basically sort of takes us through the immediate benefits that we have had with the client. Like I said, the idea around this particular solution is to give a client a head start in terms of understanding what the issues are, and we've been able to do that already for this particular pumps, and the client is well aware now of what the issues are because the system has already detected them and has already scored it in terms of how severe those faults are, and they are already trending, and they can see as those are changing. So yeah, in a nutshell, I believe we have added quite a lot of value to the client because we've given them a lot of time to be able to plan ahead and to be able to know what the problem is with their particular equipment. And at a high level, management can see the health status of the whole business unit and can dial down to the individual pumps that they have, and they can see what the health status of that is, and above all, be able to plan well in time so that if they need to change something, if they need to change a coupling, if they need to whatever they need to do, the system is going to let them know. So yeah, that's really the end of my case study. I'll hand over back to you, Zulf. Thank you.
Thanks, Shalom. If I can ask you just to progress to the next slide, please, the next one. Thank you. So just to bring it all together again, the connected reliability ecosystem is really based on three legs, if you like. Purpose-built tools, excuse me, innovative software solutions, and of course the asset and condition knowledge. And Fluke Reliability is made up of three divisions. Proof Technique, which has been in the industry for 40 plus years, has got a sound grounding in condition monitoring equipment and laser alignment equipment, along with Azima DLI, which is a US-based company that has also got condition monitoring solutions, along with automated diagnostic software. And then we have the CEng part of the business, which is the CMMS software that we have. And the idea is to bring the data from the equipment on site through the purpose-built tools that we have, the sensors and the data collectors and the laser alignment, through to a software where we can work through the diagnosis, either by the teams in field, and where the capabilities are not available, to use an automated diagnostic system to bring that to life. And then, of course, what we do with the data, dashboarding that enables you to have a look at where your condition is on the equipment that you have. And also the CEng CMMS system, which allows you to actually manage the process, the works orders, the reactive work that's required, closing off jobs, and then also pushing that data through to bigger systems for managing the whole process. If you can go to the next slide for me, please, Shalom. Along with this, we also have a very big aspect of a service department, where we can do field services where the skill set is not available on site. Some very specialized services such as central line and level line, which is used for alignment of fast-moving rotating turbine equipment. A Paraline, which is now the alignment of rolls to see that, and to determine whether they are parallel to each other, especially in paper machines and molds. And then, of course, we do vibration assessments and balancing of turbines, laser alignment, geometric alignment. We also do have a calibration and repair center, and we also have a service of doing remote diagnosis for sites where the data is collected locally, and the remote diagnostic team can then do the analysis and report back. Alongside that, also we manage training. So the category 1, 2, and 3, and 4 vibration analysis training, as well as more product-based training on the equipment that we have, and finally also on specialized training on roller bearings, gearboxes, and machine diagnostics. So that's really some of the capabilities of Fluke Reliability, and I'm going to hand back over to Dr. Leslie.
Thank you, Zolf. Now we have a poll for you, and the first question that we have is, what data are you currently collecting from your equipment, and what additional monitoring capabilities will be required? So this poll will come up. It's a multiple choice question, and you can choose multiple answers. It'll be great to understand your experience and where you are on your journey. We're still receiving feedback, so I'll pause for a bit. Looks like the majority of people are collecting condition monitoring data, and also have visual thermal inspection data as well, which they can leverage. So from that perspective, that leads us to the next question, which is, would you like to undertake a connected reliability assessment? By way of background, we do, Fluke does have a connected reliability assessment that you can undertake to see where you are on your journey and understand what the next steps are you can take to progress on that journey, along that journey. Still got some responses coming in. Okay, so majority would like to undertake that connected reliability assessment. Thank you very much. We've reached the questions part of the webinar. Robin, I don't know if we've got any questions at all.
Hello there. We do have a few questions. All right, give me just a second. Let me weed through these a little bit.
Okay.
All right, our first question. For a company just starting its journey towards connected reliability, what's the most important first step you would recommend?
I'll pass that one on to Zulf. Zulf?
Thank you. I would say that the first step would be to know your plant. You need to know where you're at right now and what are your problems. Where are the faults mostly coming from? And then to try and close that gap first. You also need to look at where your skills are based right now and how to close that gap. So it would be both. You would need first to look at where you're at, what your skill set is, and then look at how you'd close the gap. If there's a follow-up to that, or Shalom, if you want to add extra.
I think that was good. Thank you, Zuf.
Right. More questions are coming in. We'll see how many we can cover in the next 15, 20 minutes. What is the value of AI analysis? What role will humans play in the future of analysis? So it's a two-parter.
Okay, perhaps I'll kick that one off and then hand over to my colleagues as well to answer. So the value of AI analysis comes in to address the issue that we're receiving a lot of information. There's a lot of complex calculations that need to be undertaken as well to understand, if you go back to the statistical prognostics, the viable data and so forth, to understand failure rates and mean time between failures and so forth. So if you're in a position to have that data readily available to inform the platform, then it becomes a much more powerful platform, and that's where we leverage AI to provide us with that support. Not sure if you've got anything to add, Zulf, Shalom.
I'd like to add, I think AI is the holy grail. It's what we all hope to get through to as quickly as we can. I think it's been around for some time, especially in the condition monitoring field. It's been around, but I think we have challenges. It's not going to replace vibration analysts anytime soon. I think that we will have a system that will start to be able to learn very quickly as we are able to increase the technology around the crunching the numbers. But as you can understand also that the complexity of equipment on site, even the very basic equipment like a pump set, has so many variables that AI is not yet ready to take over to let me go to the beach just yet, I think.
So, Shalom.
Right. Sorry.
Yeah, look, I think in terms of the role that people play in the future, I think like Zuf said, AI needs to be taught. You know, since it's still at the beginning of things, we still need to sort of moderate it so that it works for different environments and so on. But I think it's something that we ought not to shy away from because it's technology and it's here to stay.
Absolutely. I guess that answers the second part of the question, Robin, as well. What role will humans play in the future? I think we see that there's always going to be a role for humans there, and the data and AI will just help us leverage the complexities around this in a much better way.
All right, next question. Do you have a mobile version of the solution? If so, does it have the same functionality as the web version?
Zulf?
So with the aspect of the automated diagnosis, the system requires to be on the web. This way, they can deploy the automated diagnostic engine to the data across multiple databases. At the moment, we don't have a standalone or on-premise solution for the automated diagnosis, but for the data, the database, and for the software, which if you are able to do the analysis yourself, there you can then use an on-premise solution, but you won't have the aspect of the automated diagnosis on top of that.
All right, next question. You highlighted various condition monitoring technologies like vibration analysis, infrared thermography, and oil sampling. How do you determine the right mix of these technologies for a specific industrial facility?
So typically, you would have certain technologies that are better suited for specific machines, and then you'd have some that are more generally used across. If you were to look at anything that has lubrication via oil, then oil analysis is always the best fit to sample the oil, have it analyzed, look at the wear debris. You can tell a lot about the condition of the equipment based on the condition of the oil. In some cases, you don't have the ability to do that. So then you must look at something else. Vibration is the next one that covers maybe 80% to 90% of your plant. From vibration, and if you add a little bit of temperature monitoring as well, you can monitor typically all of the equipment on your site, except for where thermal imaging does a better job on electrical equipment. And that is the progression that you're looking for is to pick up the problem as early as possible. So if you were to take, for example, a gearbox, like I guess used as in my example on my slides, was that with oil sampling, you will probably pick up the fault months ahead of time. And you can then see the historical trending on that and determine when the failure will take place or when it's time to react. With vibration, you need to have a certain level of failure, or let's say wear, before vibration really starts to take hold. And that vibration increase will depend or will be determined by the amount of wear that you're getting on the components that are failing. So that will then pick up the failure a little bit later than oil sampling. Once your wear gets to a point where you've now got heavy friction, then your temperature changes. So that would be the closest to the failure point, is when your temperature starts to spike. So if you were to look at when to pick up a fault, it's always oil sampling first, vibration next, infrared after that. Acoustic is a little bit on the side, and it mostly is for where you have leaks or piping, where the ultrasound is so high that you don't pick it up as early on vibration. It's not rotating equipment, it's now flow, so acoustics works better there.
All right. The next question I'm going to ask is actually a consolidation of two questions that are very close. Is the data that is collected stored, is the data that is collected using the CMMS software stored in the cloud or on-prem somewhere?
Okay, so the CMMS system itself is on the cloud. The data that we have from the condition monitoring software can be both on-premise, on your server at site, or on the cloud if that's your preference. There's a lot of questions around whether security of data is an issue on cloud. And I think that we can address that quite easily. I think we're using the latest ISO standard for data security. The systems are very secure. They're as secure as your Microsoft Cloud versions or any of the other bigger brands, IBM, etc. So yes, you can have some data. The condition monitoring data can be on-premise. Typically, though, the CMMS is on the cloud.
Thank you. Next question. In the case study at the water processing plant, what was the most significant challenge they faced in moving from a reactive to a predictive maintenance strategy?
All right, thank you. That's a very good question. The biggest issues that they were having there was bearing failures, particularly on the motors, and basically that's the reason why we then went with the Azima DLI, because they couldn't pick up any issues. It was more of quite instant failures as far as they're concerned, because there's nothing to do, nothing to monitor those particular motors with. And secondly, to that, issues to do with alignment. And because now, they are fairly quite new, I think, in the space of using alignment technology. And also, based on that, our system is able to then help them in terms of diagnosing alignment issues. And so those two were the biggest issues, bearing wear and alignment issues. And those are quite easily solved with our Azuma DLI solution.
All right, I have another question for you. You mentioned the importance of having the skill set to use the technology and to analyze the data. For companies that currently lack those skills in-house, what options do you suggest to bridge the gap?
So typically, this is now more a commercial aspect. When you are out looking for condition monitoring equipment, you will come across different levels: entry level, advanced level, or expert level. And sometimes you're maybe motivated to go with an advanced level, but your team doesn't have the capacity or the capability to work with the equipment required. When starting off, I always recommend that you start at entry level. This is mostly the easiest equipment to work with. It also does give the results that you want at that entry level. And once you start gaining the trust of your team and of your management team, that the money you're spending is actually making sense for the business, it is then easier to motivate for the higher end equipment. As for the training, we find that in the fields at the moment, condition monitoring, although known as a technology, is not really taught at your industrial or your engineering schools to a level that you can have proficiency to come into the field and start using it immediately. So there's always product training available, and a good product company that's going to supply you the equipment will offer you the training. The worst thing you can have is have a good set of equipment and people that don't know how to use it. So it always goes hand in hand. You need to have the right product with the right training at whatever level, entry, advanced, or expert. That covers the product training, but on the analysis side, there are specifically vibration analysis training for different levels, 1, 2, and 3. It's managed by ISO or Mobius or the British Institute of Non-Destructive Testing. So these are certification training that allows your team to understand the concepts that are looked at in condition monitoring and vibration, and then allows you to do the analysis to a level that you'll be competent at. I want to add, though, that certain companies have also seen that this is lacking in the field, and hence this is where we're developing on the automated diagnosis. So sometimes you might step away from an entry-level device to a more advanced level one, like a wireless system, which then enable you to use or to piggyback off the automated diagnosis that's built into the software. So there's two approaches. Either you train up your team, or you buy a product with training, or you work with service providers that can do the analysis for you.
All right, we have time for a few more questions. The next question I have is a very simple one. How do you get the assessment?
That's a
So
very
we have a QR code
yeah.
that we can share, and you can go through to the QR code. It's a very basic assessment just to see where you're at right now. And it's followed up with a call or a Teams meeting where we can discuss in detail what your needs are and how best we can provide a solution for that.
And since you mentioned the QR code, is that in the slide deck? Are we able to bring the slide deck back up and show that QR code? Or is there another way we can share that QR code?
I will bring up the QR code just now and share the screen.
There we go. I know I'm going off script a little bit, but since it was a direct question, I thought we should share that QR code. And while that QR code is up, I'll ask the last question, and it is, have you done any solutions to local government equipment like HVAC?
Shalom.
Perhaps I could
Not.
go with that one.
Go for it. Go. Yeah.
So if we're talking about HVAC and conditioning, air conditioning and cooling equipment, we haven't got anything, and I think we're talking local South Africa. We haven't got anything yet in play, but we do have in other parts of the world where we've had wireless sensors fitted to HVAC fans and pumps, and they work quite well in that environment. If there's a follow-up to that, I'm happy to answer, but I think I might have just covered it.
You did. And I want to say thank you all for a great presentation and lending your expertise today. And to you and our audience, thank you for joining us today. As a quick FYI, when you exit GoToWebinar, our audience will see a window that pops up with a very short 30-second survey. We would appreciate your feedback on today's session. It helps us to continue to bring you great content like today. Thank you all for joining. Thank you, gentlemen, again for your expertise, and I'll close the event now.
Thank you.
Thank you.
Thank you. Bye-bye.